I asked you to solve problem 6.4 in the book using the impeached dataset. That's one of your study questions. And the reason why I do this is so you have a clear understanding of how to estimate a regression and interpret the coefficients and other related output. So today I'm going to go through how you would solve that problem and answer the specific questions to help you review for the mini exam, as well as to better position you to solve the last few question asks on problem set 2. Your second problem set asked you to work with the impeached dataset. Just to give you some details about the dataset itself, on February 12, 1999, for only the second time in the nation's history, the U.S. Senate voted on whether to remove a president based on impeachment articles passed by the U.S. House. Professor Alan Reifman of Texas Tech University created the dataset consisting of descriptions of each senator that can be used to understand some of the reasons that the senators voted the way they did. The data are taken from the Journal of Statistics Education. So the relevant variables for problem 6.4 are conserva and support. Conserva is a conservatism score. The senator's degree of ideological conservatism is based on 1997 voting records as judged by the American Conservative Union. The scores range from 0 to 100, where 100 is the most conservative. Support C represents the stated voter support for Clinton, or the percent of the vote Clinton received in the 1996 presidential election in the senator's state. I've already typed the content in the do file that tells Stata to open the impeached dataset, save the do file, and save a log file. So I'm going to go ahead and run the first two lines. So it would be useful to have the book in front of you, question 6.4 in the book. Go ahead and pause this video and grab your book if you don't have that already in front of you. Part A asks you to create a scatter plot and use it to verify that the data have an approximately linear shape. So there's a nice command that you can download called AA-plot. That allows you to produce a figure with a scatter plot, with a superimposed predicted line, as well as it inserts the regression equation and other relevant output. You need to install the command AA-plot on your laptop or your computer. It's quite straightforward. To do that, I've already done it here, but to do that, you would type something like in your command window, search for AA-plot. And then you can see that a window pops up and you can click on this blue line that says AA-plot from HTTP. And you can push click here to install. I've already installed it, but let's just go ahead and install it again. Okay, so all files already exist and are up to date. We can go ahead and close this window. Okay, so now that I have it, AA-plot in Stata, what I want to do is go ahead and create a scatter plot to answer part A of the question. I'm going to do that by typing AA-plot, conserva, support, C. I'm going to run that, or execute that line. See how nice this scatter plot is? So it not only produces the points on the scatter diagram, but it also superimposes the predicted line. It gives you the predicted equation. It gives you the R squared. It gives you how many observations are in the data set and some other relevant information. So I find this a quite useful device to have in my toolkit. So I get the scatter plot and the related content needed to answer a lot of this question. First, does the data give a linear shape? There seems to be somewhat of a linear relationship. The important thing is that there doesn't seem to be an obvious curvilinear relationship. So it seems okay to go ahead and apply the tools that we've just learned in Chapter 6. So Part B asks us for the correlation between conservatism and state voter support for Clinton. Well, we could go ahead and compute the correlation ourselves. That would be the easy thing to do. So let's go ahead and do that just to refresh our memory. By the way, you could also use the pwcore command. And you can see here that the correlation coefficient is negative 0.447. So the answer to B is lowercase r equals negative 0.447. But let's get that figure back up. Where are you, figure? Let's get that figure back up. I don't know why it's running away from me. I have to reposition my windows. But we have enough information from the figure to answer this question too. We know for the simple linear regression that capital R is equal to the absolute value of lowercase r. Remember, capital R is a measure of goodness of fit. Let's go back to our do file. So capital R is equivalent to the absolute value of lowercase r, which is the correlation coefficient. If I can go ahead and find that graph that keeps disappearing here, we know that r squared is 19.9%, which is the same in decimal form as 0.199. Okay? So if we want r, we simply take the square root of r squared. Okay? R is the square root of 0.199. Okay? Which is 0.447. Now, the problem is we don't know what the sign of little r is without additional information. But we can still use information from this scatter plot to figure out whether the correlation coefficient is negative or positive. How do we do that? Well, first of all, we know that the estimated coefficient on support is negative. We also can see from the visual diagram that there's a negative correlation or negative association between conservatism and state voter support for Clinton. So based on both the r squared and the association between conservatism and voter support being negative, we can pretty much answer the fact that the correlation coefficient is negative 0.447. So answer B is that r is the square root of 0.119. On top of that, we know that there's a negative relationship between the y and x variables. So little r, or the correlation coefficient, must be negative 0.447. Okay, so that's another way of figuring out how to answer that question without being able to directly type correlate or PW_core. So part C asks us for the value of r, and we know that r is 0.447 because it's the absolute value of the correlation coefficient. And we just went through that we just went through the fact that r is also equal to the square root of r squared, okay? So we know that the answer to C is 0.447. What does R tell us about the goodness of fit? It tells us that it's pretty strong because it's close to 0.5. Part D asks us for the linear regression equation for predicting conservatism from the state voter support for Clinton. And the beauty about this AA plot command is, look, it already tells us what the regression equation is. But by the way, if you might be asked to be able to figure out what the predicted regression equation is based on output from Stata. So please be sure you know how to figure out what the predicted regression is based on the Stata output as shown in the table. I'm sorry, in the book. So this is quite simple. The answer to D, because the command gives it to us, is that the equation is conserva equals 164.91 minus 2.4884 times support C. Part E asks us for the interpretation of the slope. So the estimated slope here is negative 0.24884, which means that a unit increase in support for Clinton is associated with a 2.4884 decline in the conservatism score. Part F asks us for the interpretation of the constant, and the interpretation of the constant is not meaningful. Why? Because you can see from the scatter plot that the values on the x-axis only start at 30 rather than 0. So Part G asks us to use the regression equation to predict the conservatism score for a senator with voter support of 50. Here you just take this formula and plug in the value of 50 for where support C is. Quite simply, the answer for G is the following. 164.91 minus 2.4884 times 50, which is around 40, depending on how you round your decimal points. That's all I have for you today. Please feel free to contact me or the TA if you have any additional questions. Good luck. Take care.